It is very interesting to see that the exact same series was asked twice in the last 4 or 5 years when it comes to JEE mains, and this only highlights how important it is for students to be able to evaluate special series such as this, not only for JEE but when it comes to your higher knowledge when you go to engineering or other math dominated fields. Being able to evaluate what we call telescopic series like this is very important, and so through this question we will try to understand the general method or the general logic as to why these methods work when it comes to finding the sum of such series. I have already dedicated a complete video to it using another previous year's JEE question, which was incidentally of trigonometry, but where the same logic was to be applied. So this is the series, and again I am keeping it general from k is equal to 1 to n because you need to understand the underlying concept and not just being able to solve this particular problem when k varies from 1 to 10 or r varies from 1 to 25. Instead, well, let us take it in general when k varies from 1 to any number n. Now, as I said in that previous video also, focus on the denominator by also keeping the numerator at the back of your mind. What this means is, whenever you have series like this, the denominator is often factorizable in a way that you will find the denominator or you will find a constant. So in this case, let us focus on the denominator. It is k raised to power 4 plus k square plus 1. So you can complete the square. So this will be k plus 1 whole square minus k square, completing this square, right? And can apply a minus b, a plus b, you get denominator as a product of two factors. And this is exactly similar to the VR method, right? In there also you have to focus on making denominator in such a way that you get these two terms. And as I said, keep the numerator in mind. So in numerator you have k, and the difference of the factors in which we were able to break the denominator is 2k. So you already have a k in the numerator, just multiply it by 2 and divide it by 2. So what we will get is half 2k upon k square plus k plus 1 into k square minus k plus 1. So just take this half outside because it's a constant, and then you will have from 1 to n, just subtract this 2 because that is how we got 2k, right? So when you subtract, then again open it. So in the first term this will get cancelled, in the second term this will get cancelled. So you will finally get an expression of this kind. And now you will see that when you start substituting values, because now we have got it in the form of sum VR minus VR minus 1. What this means is basically we have got the required sum in such a way that once you start substituting the values, terms will start getting cancelled out. So put k as 1, you will get 1 upon 1 minus 1 upon 3. Similarly, k as 2, 1 upon 3 minus 1 upon 7. So start putting k as 1, 2, 3, so on till, and the last term is n. So when you put n, you will get n square minus n plus 1, n square plus n plus 1. Simple as that. And as happens with telescopic series, like a telescope collapses into itself, right? And you can see only the edges or only the end two plates. Similarly, the series will start collapsing. That is, sorry, all the middle terms will start getting cancelled, and finally you will be only left with this one term and this one term. So the general sum would be 1 minus 1 upon n square plus n plus 1. But remember, in this particular question, as we have found this series, there would be a factor of half there. So remember to keep a half outside whenever you are trying to evaluate the final answer. So in final answer, you will just have to keep n is equal to 10 here or n is equal to 25 there, and you will get this required sum, and you will get the value of m, n, or p and q, or this m plus n and p plus q will get easily. So this is the general method of how to solve series of this kind. And in general, any telescopic series, you have to focus on factorizing the denominator in a way that you will find a numerator of a simple kind. And generally, because the series has an answer, that is why it has been given to you as a question, right? So basically you will find that the denominator will be factorizable in a way such that either the numerator is constant or in a way that the factors get cancelled out. So keep that in mind. And as I said, this channel is about the basics, which is why I focused more on the general idea of solving a telescopic series as opposed to this particular question. So for more such insights into JEE Maths, keep following the channel, watch our other videos, and keep learning. Thank you.